So I showed in a previous video that in this case, triangle PQR, hopefully you have your notes out, that there was two triangles. And I want to go through the steps now that we've determined there's two triangles. Again, we've compared side length A to the height. When there's two triangles, now how do we solve this? And there's actually two solutions. The ambiguous case is probably the hardest topic in this chapter, and the only way to get really good at it is to do lots of questions and to really internalize what we're doing here. So we said there's two triangles, so we actually solve this triangle twice. So we have the first case where that side length A, or in this case that side length P, comes in and it swings in, and it looks something like that. So we have an obtuse angle right there. And then we have another case where like it swings out, and it looks something like this. Okay, so we're going to put in our letters. We have P, R, and Q, or you could do A, B, and C if you'd prefer to do that. P, R, and Q. And we were told that this side length is 12. We were told this side length was 10, I believe. Yeah, this side length is 10. We're told this is 10, and this is 51. This is 51. And what we're going to use is the sine law. The sine law is the root of the ambiguous case, because remember that the sine of any angle is equal to the sine of 180 minus that angle. So that's what gives us that ambiguous, is the sine of 150 is the same as the sine of 30. So that's why there is that ambiguity. So we're going to use the sine law. We're going to get an angle to be spit out, and then we're going to look at these two cases. Okay, so we know that in this triangle, the sine of 51, the ratio of the sine of 51 to the side length opposite to 10 is equal to the sine of Q, and we don't know what Q is, to 12. Okay? Cross multiplying, we're going to get the sine of Q is equal to 12 sine 51 divided by 10. Okay? We're going to grab our calculator, and I'm going to go bring it over here. I'm going to go 51 sine, that's the way I do it in my calculator. You might do it differently. Times by 12 divided by 10, and I get 0.9325. Okay. 0.9325. Now using my calculator and inverse sining both sides, I get Q is equal to 68.83 degrees. So on my calculator, I'm saying that this is 68.83. Does that make sense that that is 68.83? No, that is obviously an obtuse angle. Okay, so in this case, I know that my 68 degrees is really talking about this angle right here. I go 180 minus 68.8, and I'm saying this angle is actually 111.2. Okay, so remember I said that the biggest side is opposite to the biggest angle. Well, check this out. The biggest side here is opposite to the biggest angle. This is obviously going to be a short side. In this triangle, the biggest side is right here, so that big angle is going to go there. Okay, so that's how I find that angle. I use my sine law, and I put one angle, I get my 68, and I put that on one spot, and then I go 180 it and put it on the other triangle. Okay, to find the remaining angle, let's focus on this triangle right here to continue solving this triangle. I say the interior angles are equal to 180. So I go 180 minus 112.2 minus 51, and I get my leftover angle, which is 16.1 degrees. And then I could find this last side by using the sine law. Okay, in this triangle, so now I'm looking at this triangle, I go 180, I go minus 68.8, and then minus 51. I'm left with what's left, and I have 60.2. Did I do that right? 60.2. Oh, so I was wrong. Actually, this is going to be the longest side. I didn't draw this guy very well because this guy looks really long. So that was a poor drawing on my part. So, and then to continue solving this one, I could use the sine law to find that last side, right? So again, you set up the sine law, but the ambiguous case means that you're given one triangle with the angle it spits out and one triangle with its supplement. So that's how you go through and solve this. That doesn't mean every time you get an angle side-side, your strategy is to just get two triangles. No, you have to look at these cases here, and you have to decide if there's one triangle, two, no. You have to decide what case it is. Remember, when you know you're given an obtuse angle, so if you're given an angle greater than 90, there's only two cases. Either there's no triangle or one triangle. So this page that you have printed out, I would keep in front of you for every single problem you do in this section, always referring back to this. Remember that you might not be given the letters A, B, C. You can either relabel or just know that you're talking about the height. The angle you're given is here, and you're always comparing it to the height, that B sine A. Practice makes perfect. Make sure you do lots of examples. Email me, come talk to me if you're having trouble. I can do an example with you, but this is a very important concept to understand.